Hello everybody, right, some of you will know me, some of you won't. That's all right, Nick?
Yeah.
Some of you will know me, some of you won't, but I'm Bob Eager. I was a senior lecturer and previously lecturer, previously postgrad, previously undergrad at the University of Kent, and I was teaching computer science, of course, and a bit of hardware. I'm actually an electronics graduate. So, right, you'll hear about my involvement with UNIX as we go along. So here we go. I assume that you most know about UNIX, or you know about Linux, but may not be clear on the difference. And part of what I'm doing today is actually talking about what that difference is. It's a compressed version of the history. When I said to Alex I'd do this, I thought, well, I've got this as a can already. It should be fairly easy, just update it a bit. And then I looked and it was a 2-hour talk. So I've turned it into a 1-hour talk, and it may actually have shrunk a bit too much, but we'll see how we go. It's been seen by people in the know, some of the other early UNIX people, including one particular one who was based at Kent and still lives locally, and it should be accurate. I had one mistake in it, which was about how soon Kent got into UNIX, but apart from that. So, first thing to say is that UNIX is actually a trademark, and it's actually been a trademark almost forever in terms of the names. But the name UNIX is used, as you probably know, informally for all sorts of things. What I would call UNIX derivatives, which are the BSD systems, so FreeBSD, OpenBSD, NetBSD, Dragonfly BSD, and all the others. All of those are what I would call derivatives of UNIX, because they actually derive directly from the original code. There's UNIX lookalikes, what I call jumped-up wannabes, i.e. Linux. Right. Linux is a different system altogether, but it's made to look the same. And there are many Linux-type systems in all incarnations. More about that later. Then there's real UNIX. Now, I used to have quite a list here, because there were quite a few of them, but really these days there are very few. They're entitled legally to use the name UNIX. And they don't, as it happens, because they call it MacOS. MacOS has got to, and in fact what's underneath MacOS is a derivative of FreeBSD, but you have to dig really deep to find that, and it's not as true as it used to be. But most of the other systems you might find that you might call real UNIX are now obsolete, they just don't exist anymore. Sonos, things like that, Solaris. So, this is in 3 phases. I tend to do it like that. The 3 phases are really the phases of development based on what hardware was available. And UNIX was internally developed by Bell Labs in the States. Bell Labs didn't know they were developing it. The people who worked for Bell Labs were given Friday afternoons, basically, to do their own thing, whatever they liked, using the facilities they could find. And these 2 guys, particularly Ken Thompson and Dennis Ritchie, decided, yeah, we're going to do that. They were really the prime movers, but lots of other people helped. But if you look at the original UNIX directory tree, you'll only find 2 users in it. One is DMR, which is Dennis Ritchie, and the other one's Ken. But Bell Labs was the research arm of, as you probably know, of Marvell, the main US telephone company, which eventually got turned into AT&T, or absorbed by AT&T. And so they decided they found this spare computer lying around, and they would do something with it. And the name was a play on Multics. Multics was a multiple user system. It stood for Multiplexed Information and Computing Service. And it was Honeywell mainframes. And I've seen it running, and it was quite impressive. And right up to the year 2000, they were using Multics, and people were using Multics. But it was a big system. And Ken and Dennis really didn't want to do that. They were much more interested in doing things on a small scale. And so they said, let's have a single user system on this spare computer we've got, which was a thing called a PDP-7, actually. So they called it UNIX, single user system, and then they UNICS, it didn't look right, so they changed it to UNIX. But the whole point about it was that it was turned out not to be single user at all. So first edition, you might call it, the very first version of this was on a spare PDP-7, PDP-7 18-bit machine, as a lot of the early DEC systems were, it was capable of, this UNIX system was capable of building programs and running them, and it was capable of doing text processing. And that was something that actually Bell Labs were quite interested in, the idea of being able to do text formatting and everything else. This is way before we have what you see is what you get. It's a question of doing markups in one way or another in order to produce a nicely formatted document, multiple fonts, all the rest of it. But that was quite early on, up to about 1971. By 73, they'd written this in assembler, by the way, because there wasn't anything else. They developed a language called C, and I'm sure you've heard of C. C was based on a language called B, B was actually looked pretty well like C, except that it was typeless. And B in its turn was based on something called BCPL, Basic Combined Programming Language, which was a cut-down version of another language called Combined Programming Language, which never actually saw the light of day. BCPL did, and I used to run the BCPL user group. BCPL is a completely dangerous language. It only has cells, and you can put whatever you like in them. Put a floating point number in, pull it out as an integer, put a number in and pull it out as the address of a procedure. Do whatever you want. Nobody will stop you. It gives you the gun and everything else. They say that about C, but it's actually worse here. You can shoot yourself in the foot really easily. By 1975, they got up to 6th edition. They were developing about one per year. And it hadn't left Bell Labs at that point. And then they decided they would let other people play with it. But they're a bit wary about letting commercial companies use it, and they actually restricted it just to academics and researchers and nothing else. So University of Kent got it in July 1975, and that's when I started using UNIX, so it's 48 years ago and a bit. It was only the second system in England, and it was the third in the UK, the third one being at Heriot Watt near Edinburgh. The other one in England was Queen Mary College at the time. So it was a very early version of UNIX. I tell you, for example, that those of you who know Unix commands, the change directory command, you had to type chdir, T-H-C-H-D-I-R. There was no abbreviation. And there was no aliasing, so you actually had to type that every time, which was a pain. That soon changed. Our copy of that arrived on 3 RK05 discs, which are about that much in diameter, about that thick, cartridges, 2.4 megabytes each. We only had 2 drives. So those 2 drives were the system and the users, but if you wanted to go and read a manual page, you had to actually dismount one of the discs and then go and read the manual page. So a lot of printing out went on. And that machine was a PDP-11, Digital Equipment Company, one of their PDP-11s, 16-bit machine. It had 112 kilobytes of memory, so not a great deal. Tens of thousands of pounds, obviously. It had 2 disk drives, it had a terminal with a printer, and so on. And it supported about 6 users, and that was basically the Kent computer science cohort for each year. It was about that at the time. First cohort was 4, and it worked, but remember, we had no networking. Networking was in the future. So all these terminals were actually quite near the PDP-11, and they're all hardwired, and you had to go into that room to use them. No other way. If you want to try running that version, you can. There's an emulator available, and you can actually run UNIX 6th edition on it and plough your way through typing chdir and all the rest of it. The Kent system on the PDP-11 ran for about 5 years, and the only reason we stopped it was because we had a much better system, which was on a VAX. Now, some people will know about VAXes, some won't. The VAX was a super mini. It was quite revolutionary at the time. A lot of bang for your buck, 32-bit system, but not a mainframe, and it was only in about 3 or 4 cabinets, so it was something that you could fit into a lot of places. But let's just go back to the PDP-11 for a minute and look at it. We probably had about 10 of them at Kent at one point, and we had one front-ending us to a bigger machine in London. And we had a couple of UNIX systems, We had other systems we were teaching programming on, and so on. I own 4 PDP-11s, real ones, and 2 of them are in storage, 2 more are in my workshop. It's got 16-bit data. It has up to 22-bit addresses with some jiggery-pokery. And the smallest ones typically would be about 56 kilobytes. A strange number is because 8 kilobytes are memory mapped input output and stuff like that. And up to 2 megabytes at the top end you can get. And you can get any peripheral you like, discs, tapes, whatever, it's all there. Printers, paper tape readers, very popular in those days, and punches. Card readers, card punches, punch cards. But particularly lab interfaces. One of the things DEC were particularly keen on was having interfaces, and they would give you all the possible hardware information you needed to interface something to one of their computers. Some machines were in 42U towers, several of them. Others were in desk-side cabinets. They actually had a desktop, well not desktop, desk side. If you imagine a sort of tower machine sitting beside a desk, they had one of those for a PDP-11. It was a bit deeper than most, but apart from that it was there. Now, I've got some pictures just to show you quickly. That's a PDP-1140, which is what we were running ours on. And you can see you get these nice hand switches. There's actually 22 switches there which are labelled. 16 lights on the bottom row for data, 22 on the top row for address. And below those 2 coloured bands are lights which light up and you can read off the bits. I do like having blinking lights, it's really nice. The ones on the right that are labelled just below where it says PDP-1140 are actually for the telling you what mode the machine's operating in and everything else. And the little group of keys to the right, the white ones are dummies and the rest are things like halt, enable, continue, examine memory, deposit in memory and so on. So you can do everything from those keys. And I'm just at the moment building a replica PDP-1170, which has much the same kind of panel. It looks very much like that. But it's 60% of the size, so it's about that big. And it's just the front panel, and behind that is a Raspberry Pi running an emulator. That's an entire system apart from the disks, which I didn't manage to get into the picture. So you've got the CPU there. Immediately above it, that strange thing there is actually paper tape. Because the way DEC produced paper tape, when you punch paper tape, it's automatically fan folded. So you get a little block of tape about that long, all folded backwards and forwards. So you never had to wind it up. It was all in theory anyway until you dropped it. And on the top left there are the tapes, which I'll mention in a minute. The console terminal there is something called a DEC writer. In fact, that looks like nothing quite like the DEC writer I've seen, but it's a similar idea. It's a terminal with a reasonably fast dot matrix printer built into it. So that's your printer and your terminal all in one. This is a famous Ritchie and Thompson themselves with their PDP-11. In fact, 2 PDP-11s. 2 teletype terminals at 10 characters per second. The first 2 cabinets on the right are mainly racks of tapes in little boxes about that big. The tape drives you can see further along, there's 2 of those, 2 sets. And then on the far left, just by his head, are 2 disk drives, which take those cartridges. So that's quite an early picture. Everyone shows that picture. It's obligatory to show that picture on any talk about UNIX. And these are the tapes. The tapes, as I said, they're about 10 centimetres diameter. They've got tape which is quite wide. It's nearly about 20 millimetres wide, something like that. Everything's recorded twice on 2 tracks. And it runs quite fast, and it stores 360K. So you can just about get that in your pocket. So that's the equivalent then of a USB stick now. And students would carry their programs around on it. Quite robust. Right, a bit more about UNIX. The 7th edition appeared actually a bit later on in 1979, because 6th edition was getting hacked around all the time and there's a lot of stuff going on. And the thing about 7th edition was that it had a lot more stuff in it. and it didn't really fit properly on a small PDP-11. The PDP-11 only gave you, effectively, no matter how much memory you had, you could only have the operating system in something like, I think it was 48K of memory, because you had to have an 8K area for getting to the user space and another 8K for input-output. So unless you had an expensive PDP-11, like the one I'm just building, you couldn't run it. Well, you could, but you had to reduce data areas, which made it very slow and so on. Now, at the same time, back in the USA, at the University of California at Berkeley, some graduate students mainly decided they would hack it around and make it better, for some value of better. And it was quite good. And they called this the Berkeley Software Distribution, or the Berkeley System Distribution. Everyone calls it BSD these days. It was also a tight fit because it had the same problem, but it included networking. This was before TCP/IP was really a thing, but it did do networking all the same. We didn't have an expensive PDP-11 down here in Canterbury, so we never really ran that. We played with it. I played with it, but not for very long. And it's often said that only two important things came out of Berkeley at the end of that decade, and that was BSD and LSD. So, you know, and that one could explain the other. So there we are. Okay. Now, the thing about the Unix was that it was only being licensed to people who were academics or for teaching graduates, and nothing else. You got the full source code, that's no problem, but you were not supposed to do anything else with it. Certainly not show it to undergraduates. And at Kent, we didn't show it to undergraduates, but I was a postgrad, so I didn't care. But a guy called John Lyons at the University of New South Wales, of course he was Australian, wasn't he? So, you know, he sod that, he says. And he decided to teach undergraduate operating systems with it. But he didn't want to sort of print out the source code in time, so he had the Unix kernel source code made into a book. And he went further than that. He wrote a second book to go alongside it, and you could open them side by side, which is what you needed to do, in landscape form. And the second book explained how the kernel worked, and it had comments for every line of code to explaining what that code did, apart from some famous ones. And there were chapters in front of that which explained, first of all, what the architecture of the PDP-11 was, and its assembler language, and then it explained a bit about the C language as well. I'm not sure that he ever really explained the famous line which is commented, "You're not expected to understand this." Some of you have probably seen. I have a t-shirt with it on somewhere. And it was a really, really interesting book, possibly the most interesting computer science publication I've ever seen. And I think most people would agree. And they circulated it internally, and they also sold it to Unix licensees, because that was legal. What they were doing with teaching it to undergraduates is another story. Now, when the print run ran out, Bell Labs said, "Oh, we'll take that over. We'll do it all for you from now on." And then they started slapping restrictions on it. You know, 1 copy per site, and that was it. And by 1978, you couldn't get one for a lot of money. They just disappeared completely. So that was very sad. But of course, it didn't stop the undergraduates. I have an original copy. I have the one that Kent had. It was given to me. So I'm very proud of that. Despite the books being under copyright, they were described as the most photocopied book ever in computer science. And that's probably true. But they did then republish it many years later. You see, the Unix sort of intellectual property moved around a lot. And it actually moved around, it went through the NetWare people, it went through a couple of others. And eventually, whoever had it said, "All right, we'll republish the book." And they published it as a single book, which is a pain because you have to keep flipping backwards and forwards. But you know, you can still do it. And that's the book, and you can buy that. There are copies around. I bought my copy in Blackwell's in London many years ago, and at the moment Blackwell's have them on sale for about 27 quid. There are other places that are selling on Amazon and so on for over 100, but that's silly. But that's the book. And you notice there what we have is these students furtively photocopying the book in about 1980. And you probably can't see too well, but what it says on the right-hand guy's T-shirt is, "Beam me up, Scotty," which is completely irrelevant, but still. Yeah, I'm just pointing it out there in case people didn't see it. Okay, so moving on, let's go on to the 32-bit systems. Clearly the VAX was coming, and that was important. So they decided to transfer UNIX to the DEC VAX, which was a much more powerful machine, had proper virtual memory hardware, which the PDP-11 didn't have. You know, 8 base and limit registers, and that was it. And they were quite affordable compared to buying an IBM 360 or 370 or whatever. And the VAX was actually very influential for many years after that. It had its own operating system, VMS, which was pretty good, but it wasn't Unix, and it cost money. The thing about Unix was it was free. We never ran Unix on any of our, never ran VMS on any of our machines in the School of Computing. We only ever ran Unix. The machine architecture of the VAX was really like an outsized PDP-11. Had the same kind of registers, but more of them. It had the same kind of instructions, but more of them, and bigger ones. And it was really a complex instruction set machine. Some instructions actually took 5 operands and could be up to 37 bytes long, which is quite incredible, in the worst case. But this meant that if you knew how to program a PDP-11, you could program a VAX, and so it was quite easy to move Unix across to it. And of course it had the proper virtual memory support. And the other thing was that in order to sell the VAX, they had to make sure that the peripherals it drove could include all the ones the PDP-11 had. So if you knew how to drive a PDP-11 peripheral, you could drive a VAX peripheral. So device drivers didn't take too long either. And they did try other machines. The Interdata 32 was one, but really the thing at that point that really dominated was the VAX. If you had Unix, you were running a VAX. I've got 3 VAXes, and two of them are at home at the moment. One's in storage, and I haven't done anything much with them recently. I need to get some new disks. Right, so BSD became the de facto standard for the VAX because although Bell Labs had actually produced this, they called it UNIX 32V, V for virtual, they didn't do much with it, and it was a bit crap, to be honest. And it turned out that the BSD people were a lot quicker, and they very quickly produced 4.0 BSD. One never quite knows where 3 went. Subsequent releases I had from Berkeley were 4.1, 4.2, 4.3. And there is a 4.4, but you can't find that anywhere. You can find the source code and you can get a book about it. You can't actually get the rest. And you can run 4.x BSD on a simulator. And you can sit there running Unix quite happily. I've got instructions on my website for doing that. So AT&T were developing Unix still. And what they did, they produced something called System 5 or System V, which was a bit incompatible. The commands were different. And people who sold System 5, because they obviously let people sell it for a license fee, people who were doing that found that their customers complained that the Berkeley commands weren't present. And they ended up having both sets of commands in the same system. And sometimes you had to select one or the other because they were the same name, but they worked differently. It all got very messy. And a lot of vendors actually did sell System 5 for a price. Meanwhile, other vendors saw this, and they formed something called the X-Open Company, which is, when I last looked, was called the Open Group. And they produced a single specification of what a Unix system should look like. So they were defining the API, the commands, everything else. And there was a lot of messy politics involved over the next decade. And eventually the Unix name and the specification were transferred to the X-Open group. And then eventually in 1995, they ended up with a branding program. So you could go along and pay your money and call your system Unix, which hasn't really worked all that well, but still. Okay, I'm almost exactly on time, which means this next bit is either going to overrun or underrun, but we'll see how we go. this bit sort of sits in the middle. So, you've probably heard of GNU, and it's very important in the Unix world. So we need to backtrack a bit for this. If you go back to the 1960s actually, and certainly 70s, MIT, you can't say Massachusetts Institute of Technology, it's too difficult. MIT had a group of people who basically were postgrads, who've got nothing better to do with their lives. And they decided that the best thing to do was to stay at MIT and hack things around in a good way, not the sort of breaking things. And what they wanted to do was just live their lives, grow their hair, and take drugs, really. You know, they were very happy doing that. They cooperated with each other. They did a lot of good work. They helped each other. Everyone had their own area of expertise and so on. And they would freely give away anything that they'd written, you know. So if you said, oh yeah, well I need a program for doing this, yeah, I have this, you know, or I need a library for doing this, yeah, no problem, you know. They just hand stuff out. And if they were given a program to hack around and modify, they'd do it. So, you know, it worked really well. But then MIT went down the horrible corporate route, a bit like the University of Kent has, and in fact other places. Notable one was Salford. I have a friend there. And what this meant was that the university were out for all the money they could get. I know people, including one of our big UNIX people, who actually left the University of Kent because they were trying to do some work for somebody and be paid for it, and the university wanted such a large slice of the money and so many restrictions, and would spend so long drawing up a contract, it wasn't worth their while. So they just left in disgust and formed their own company. And that's pretty well what happened at MIT. And so most of the good people left. And those that remained had to use commercial software that you couldn't hack around, you couldn't fix if it wasn't quite what you wanted, and so on. And they weren't free to give everything away that they'd actually produced either. And certainly I've been through that as well at Kent, and it was a pain. So one person decided that was wrong. He said, all software should be free, as in unencumbered, not necessarily paying no money for it. Basically a software socialist, if you like, or possibly even worse than that, you know, Marxist or whatever. I'm not into politics. His name was Richard Stallman, and you've probably heard of Richard Stallman. He resigned from MIT and started a project on free software, as in no strings attached. And the plan was eventually he was going to produce a complete UNIX system that was open, free, anyone could play with, and you wouldn't be charged for using it, and so on. But you could make money out of it if you needed to. The project was called GNU, which stands for GNU is not UNIX, which is a recursive acronym. That project is around to this day, of course. Here's Stallman in typical hairy form. And just for completeness, here's what GNU looks like. That's actually their logo. And it's still around to this day. So, first project they produced was going to be a C compiler, but he already had a product, and that was something called Emacs. And Emacs was a macro system for an editor. I'll talk about that, I think, after the break, because we're nearly there. So I'll stop now, and I'll carry on talking about that editor after the break.